Okay, everyone. I'm going to go ahead and get started since I'm standing between you guys and lunch. Don't want to keep it any longer than I have to. So, everyone, my name is Peleus Uhley. I am the lead security strategist at Adobe. I've been in the industry for about 16 years. You guys don't come to these things to listen to the resume, but the fact that I've been in the industry for over 15 years is somewhat relevant to this talk, just because some of the things I'm going to be talking about in terms of design approaches for security automation, a lot of times you go and you see the presentations, like if you're at OWASP USA, you maybe saw Salesforce do their presentation on Chimera. And they're all very, very good. And Chimera is a great project, but there's a lot of challenges in developing these. I'm going to talk a little bit about the challenges as well as in addition to the things that are really good about doing security automation. And that comes from just being in the industry for a while and starting to get curmudgeon-y. I haven't grown my Unix beard yet. I'm not wearing the suspenders, but I'm getting up there. So I'm starting. You're going to see a little bit of that in my talk. And with any project you want to launch, you're going to start with what's the point of doing it. I mean, it's fun to build things, but building things for their own sake is not a good way to build good things. And I'm going to talk about different types of automation. So a lot of times you go to talks and you hear about these things about doing everything at scale and doing very large security projects as a way to achieve security automation. But not everything needs to be this Dockerized, AWS deployed, cloud scalable tool in order to be good security automation. There's other ways of achieving good security automation that's a little bit more tactical and a little bit more to the point for your organization, besides just taking Zap or Burp and running it across the cloud. So I'm going to talk about some of the things that are a little bit more tactical in terms of deploying security automation, in addition to doing the large projects. And then we'll go ahead and wrap up with some closing thoughts. But the first place you want to start with is you want to start with defining the why. Like, why am I building this? What am I going to get out of it? Because if you think about automation, like there's the great meme, automate all the things. And it's like, well, that's computer science. Computer science is automation. Technically, a vending machine is automation. Why are we doing it? Why is this different? How is this going to be a better way of deploying things? Because people have tried deploying large-scale security tools in the past, where they take something like AppScan and they deploy it across the entire organization. That's typically called the Enterprise Edition, right? And if you've been in an organization that's tried these things before, going by the Enterprise Edition doesn't always necessarily work. I mean, there's some advantages to it. If you go down to the vendor area, they'll tell you all about what does work about their projects. But not every attempt to go and deploy something like AppScan or Fortify or something like that across your enterprise succeeds. And you need to take a look at, like, how is my deployment of the tool going to be any different from just deploying the Enterprise Edition of this tool? Am I going to get something better out of it? Am I going to get something that's more meaningful to the organization? And of course, any idea can be automated, even bad ones. So you want to make sure that you're really thinking about what you want to get out of it. And then in terms of how you build it, there's different ways of doing it. When you go to a lot of security automation talks, it's always about Docker in the cloud and doing things big and doing it at scale. And so, I work with a lot of junior engineers that come to me and it's like, I've got this great idea for a tool. It's, it'll have TLS and username and password security, so it's all good. I'm going to build it with dynamic JavaScript frameworks because HTML5 is awesome. And so I'm going to use jQuery and Angular and this thing that I posted to GitHub just like 5 minutes ago. And it's going to be totally scalable because it's going to be on Dockerized instances in the AWS cloud, so we can go up to an infinite number of websites. So it's going to be this huge, massive, awesome project that I've got this idea for. It'll take me about 6 months to get to output, and it'll take me about a year to get it to prod. Actually, they usually tell me they'll do it like in 3, but in the back of your head, you're always adding stuff. And being the old curmudgeon guy, the guy who's been in the industry for a little bit, I come back with the concept approach. For my security, I use SSH, use sudo. You can edit it any way you want. You got VI, you got Emacs, you do Pico if you're really old. Still has schedulers associated with it. It's great that you can go to infinite sites, but we have 4. The tool only takes about a half hour to run. You need to run it about 48 times a day. And I already implemented it while you were giving me your speech, right? A lot of times when we're looking at the design of these things, it's very easy to get caught up in the cloud and everything's great. But when I'm talking to people about cloud automation and stuff like that, one of the questions I keep in the back of my mind is, and what if I just use cron tab? What is the value add of doing this beyond just using a cron tab job for it? And then the other thing that comes up too is like, people come to you and James got this really great idea for building this automation, and it's going to be really, really complex, and there's all these moving parts, but it's going to be so elegant when it's done. And Jane's a rock star, so Jane can deliver on it. So she's a young engineer, and she's saying this. And then if you're an older engineer, you sort of see this in 5 years, right? And you're all laughing, to keep from crying, right? Because we've all built these things, right? Because yes, Jane is a rock star, and Jane delivered, but the problem with rock stars is they get put onto other projects which have fires, right? And so they get rotated off, and then keeping this thing maintained ends up being a hard thing because she's rotated off and it's been handed off to somebody else, and there's so many moving parts that the organization just has a hard time keeping it going. So you also have to think about these things as you're going through the process. And we're still building security automation. I'm not trying to be like, oh, screw it. This isn't a security automation is bad talk. It's just trying to be honest about some of the things that you want to take a look at while you're designing these things. And getting back to the why of it, the why is really important because you can go and you can take Zap Proxy, or you can take Burp or Nmap or whatever, and you can go run it across 1,000 sites. And so you ran across 1,000 sites, and now you have this stack of reports. What happens to those stack of reports after you collect them all, right? If you're going to do a security automation project and you have no idea what you're going to do with the data once it gets out of there, if you have no idea how to process that data when it comes out, then yeah, you'll build a tool, and the tool will do exactly what it's designed to do, but won't necessarily move the organization forward, right? Because you're going to have, the teams aren't going to be prepared to process it. The teams aren't going to know how they handle the information. It may not be immediately actionable. If you get something back like blind SQL injection, those always have to be manually reviewed in order to figure out whether they're really a true finding or whether they're a false positive yet. So you want to make sure that when you're designing these things, you have a clear sense of what you're going to do with the data once the tool collects the data that's designed to collect. And there can be different goals for this, right? You might be just trying to fingerprint your environment because keeping track of all the assets in your environment is really hard, so you're not even doing a security assessment. Maybe you're building out scalable automation just to do simple inventory management so you keep track of your environment. And then that's actionable data. That's something that if you build a scalable tool to do it, you at least have something that you can do with it. Are you trying to identify the scale of a problem that you need to fix? Are you trying to enumerate the scale of something so you can get better funding around it, right? Like if you listen to Marcus Stranham's talk, he was talking about data, the need to have data in order to justify certain things moving forward in an organization. So maybe you're doing it for that. Sometimes it's just automating tedium. I mean, there's nothing wrong with just trying to automate tedium so that things get out of there. Or you're trying to do metrics, right? So have an idea of what this information is going to be used for at the beginning of your project so that you know what you're going to use the data for, how it can be deployed. And then also, as Raymond pointed out, data affects management decisions. And so if this is the first time you're doing something at scale, the numbers that you come back with may be intimidating, or they may be surprising, or they may be large. And if you start with automating the thing that's easiest, it may not be the thing that's most relevant to the organization, but the number will still be big. And that number will plant a stake in people's minds about, oh, well, that was a big number that I saw, so that's the most important thing that I've got to go solve because that had the biggest number associated with it. And that may not be the case. When you're thinking about the data and how you're going to do this, always have a plan for also how you're going to communicate that data. Because as Marcus's presentation pointed out, data is great, but data when presented in different ways has different effects. And you're going to be collecting large-scale data, and that's going to tell a pretty compelling story. And you won't necessarily know what that story is until you get all of it, but you want to make sure that you're thinking about what you're going to do with the data and how that's going to affect management and what you want to be able to tell people that you got out of this once you've run the tool. So these are all things you want to think about in terms of why you're doing it, what you're going to do with the data once you run it, and how will it improve the organization. Another type of thing to consider, especially as you're thinking about the data that you're going to collect, is that there are different approaches to collecting data and how that affects teams once they receive that data. So a lot of tools, like Mozilla's Minion or Chimera or something like that, they do a traditional web application security assessment. They're sort of automated to go and run something like Zap proxy against the entire environment and come back with results. And there's some pros and cons for doing this. One is you're using automation, you get a bit complete picture, so you're probably scanning the entire site. But it has some drawbacks too, because it's bad for statistics unless you have the ability to go and manually weed out the false positives and tune the tool so that it's tuned for the site to get better accuracy. You have the authentication, all that sort of stuff set up. And doing an accurate deployment of a web application penetration tool at scale can be hard because you have to have the configuration files for all those different environments. And so it's good. I mean, you can go and you can run the tools against the entire site. You'll get back some information. But it may not be actionable information just because you won't have solid statistics. And it's going to require a lot of tuning. And the action items may not be open-ended. Another approach that you'll see in security automation has sort of been driven by the idea of behavior-driven development. And it's the idea of creating what's known as a specific verifiable fact about the environment. And so within Adobe, we refer to these things as security assertions. So you're not testing the site for everything that can possibly be wrong with it. You're not running the entire kitchen sink of tests against it. You're testing against very specific measurable things. For instance, is SSL configured with strong crypto? Right? That is a definitive thing, it's a measurable thing. There is a right, there is a wrong answer. It doesn't require manual follow-up to figure it out. All you have to do is a handshake. You look at the crypto ciphers that come back. If the crypto ciphers match the approved list, you pass the test. If they don't match the approved list, you fail the test. It's an easy test to maintain. It doesn't require a lot of configuration. The test is fairly straightforward. There's not a lot of moving parts to it. And a lot of times it points the team to specific and actionable work because you can clearly define the problem in terms of what's wrong with the site. It does have the drawback that if you're that specific, you have to write more tests, which requires you to build up to having a lot of security assertions. So there's a little bit more label and getting a little bit more work in getting it started. But the answers that it comes back with are measurable metrics. They're meaningful. There's very low false positives, so you can do something with the environment. And the bugs that you're enumerating or the challenges that you're enumerating can also direct the team in certain directions. So let's say you go and you run Zap, and Zap says you have XSS bugs. All right, well, how's the team going to interpret that report? If you tell them that they have XSS bugs, they will see a list of things that they have to go whack-a-mole patch. And things will get fixed in the environment, and security will improve. And you'll have to keep doing it because it's a point-in-time security assessment, so you'll have to keep running the tool in terms of automation. And it'll be good. There's some value to that. But you could also ask the question a different way. Like you could ask the question about how many people have deployed CSP. And then that takes the team in a different mindset, right? If you're measuring and the reports that are going to management are about how many people have deployed CSP as opposed to how many people have XSS, then the team is focused on security mitigations. They're focused on being able to get the header out. CSP will do a lot of work across the environment for taking away XSS, the same way that scanning for XSS would, but it takes the team in a different direction. It takes them towards a architectural approach to the problem as opposed to a whack-a-mole bug. And this is something that you can empirically measure in a way that you can't with XSS. XSS is interpreted, there's reflected, there's persistent. XSS has different rankings in terms of severity, depending on where the XSS bug is, things like that. Whereas CSP is more straightforward measurement. And yeah, with CSP, you can get, over time, you can get more sophistication in terms of how you're asking that question. Like, you may just ask how many people have actually deployed the header itself, regardless of whether it's in reporting mode or not. Just the simple fact that they've actually gotten to the point that they've returned it, right? And that's a simple yes, no answer. Then over time, you get to more specific things, like do they have star in their policies, things like that. But it guides the team in a different direction than just giving them a list of XSS bugs would. And the answer is that you may need both. I mean, I'm not, projects like Chimera, they go and they run Zap across the environment, and there's a very specific reason why they do it that way. And it works with our organization, and it's a good project, right? And they have, in terms of having a plan for what's going to happen with that report, they do, because the customer can't get onto their platform until they actually address the issues, right? So they know as soon as they go and they collect all that data that an actual plan will happen because the customer has a direct motivation. If you're in an organization that where you're dealing with internal teams, that may be more different. Some organizations, the most they can do is send a sternly worded email. So you may want to look at things that are a little bit more proactive. You might want to move towards CSP and report on those types of things because they'll guide the team slowly over time towards the thing that you really want them to do as opposed to whack-a-mole bugs. So before you start any security automation project, really spend some time thinking about how is this data going to be handled? Is it going to push the team in the direction that I want to go? Does it have the data that's going to help management make better decisions and keep them focused on the things that you want them focused on? Okay, so let's say you've come up with some ideas. But another thing that sometimes gets overlooked in a lot of security automation talk is how much you can get out of simple wins that are a little bit more integrated. So, like if you go and you run Zap against someone's environment and it comes back with false positives, then you gotta go sit with the engineer to walk through all of them to see which ones are real and stuff like that. That sometimes is hard for the engineer because you ran a tool that they're unfamiliar with against their environment. And you're coming to them and saying, hey, I ran this tool that you've never heard of before, and I don't understand its output, and so now I need you to help me figure out the output to this tool, right? And for an engineer, I mean, for us, it's all crystal clear, but for some engineers, it's a little daunting because it's just foreign to what they're used to, or maybe used to in their environment. And there's different things that you can do in terms of integration into tools that they're already familiar with, and that also produces wins. So you don't necessarily have to be this outside force that's trying to push security in from the outside. You can integrate into things that they've already got deployed and put the security automation there, so it's a more natural integration with their environment, and it's not completely foreign to them, and it's a part of an existing workflow. It's not some separate workflow that has to be maintained separately in the environment. And so at Adobe, we've done a lot of this where we've used our security automation, or our security training program to get people to do projects. Thank you. That do a lot of work. So we've done, for simple compliance things, we've done checks where we integrate into Jenkins a check where it goes into Git. It looks at all the pull requests that just came in. If the pull request and the commit request were from the same person, that probably means it wasn't peer reviewed, right? And so you can fail on that. Or integrating static analysis into things. We use Maven. Maven has the ability, for building some of our projects, Maven has the ability to list all the third-party libraries that are included. This can be really useful if you want to be able to track the third-party libraries in your organization. And so we built a third-party library component tracker where teams can go in, they can put in their third-party libraries. We use an external firm called Risk-Based Security to give us a feed of all the new CVEs that are coming in and what libraries they're associated with. And then this tool can go and match up the feed with what they've got deployed and tell them when their third-party libraries are out of date. And it can do other things too, like it has the ability to put comments next to things, like just because the third-party library has a CVE against it doesn't necessarily mean it's applicable to that environment. So OpenSSL has a problem with skipjack. You don't have skipjack enabled. Maybe the team can pause on that. So you can say whether it's not affected. They can track whether or not they've logged a bug for it, or they can just say not applicable. And we use it not only just for third-party libraries in the traditional sense of the word library, but I included a couple examples here where it's actually a third-party component. So you can use it for feeds of Apache and actual full applications as well. I already mentioned the Git review checker. This is also good for compliance, where you have to prove that code review happens. So you can go ahead and ensure that it happens. And doing these sort of inline processes are great because they sort of meet your traditional SMART goals. They're very specific. It's not an open-ended problem. There's a beginning, middle, and end to the project. It's It's measurable because there's a fast pass-fail results. It's actionable. And it's relevant to the team because you're integrating into the things that they're already using, right? Use those API extensions of Jenkins, use those API extensions of SonarQube or Git or things like that, and integrate into the tools that they're already using. You just add little small tests that are in the workflows that already exist, as opposed to looking for building your own thing that's separate from the environments. So if you're going to go for the big thing, there's always tons of questions, right? And you have the traditional build versus buy cycle. And it's never really a decision. It's just sort of like a never-ending cycle more than like a definitive decision, right? Like you're a startup. Anything that's not core to the mission gets outsourced. So you buy. And then you get a little bit more money, you get a little more staff, and you're becoming cheap because the money's trying out, so then you decide to build. But then you have to remember your maintenance it, so then you go back to buying again. And then you get upset with the vendor, so you bring it in, and then the guy quits, so you go back to buying, and then you get an intern, because interns solve everything for really cheap. And then so you get the intern to do it, and then you realize that interns don't always build the best code, so you go back to buying the solution. And I can't really help you with that problem. It's just sort of natural to the way of doing things. But there is a lot of stuff in the borrow environment that you can steal with. Not everybody publishes their code for their projects. Like you hear, like Twitter hasn't published SADB, which is one of their tools, right? But the ideas are there, and they do a lot of conference talks around them. So even if you don't know, even if you can't steal the source code itself, there is a lot of examples out there of projects that have been deployed that give you the architecture and allow you to steal ideas from the environment. And in some cases, there's even solutions like ThreadFix where it says, okay, let's say you're an enterprise organization, you've already deployed AppScan and maybe WebInspect, and you've got basically every vendor in the RSA-4 deployed out there trying to do some sort of automation. There are solutions like ThreadFix which just say, well, what if I just pull that information into a central place where you don't throw it out and start over, you just try to get all the reports into a central place. And that can be a way of just using existing automation that you have. So if you go and you look through these, there's a lot of them. I gave a talk last year where I talked about the differences in behavior-driven development tools that are out there. They all will allow you to run those big tools like Zap or Arachne in the environment. And they point you towards a security assertion model where you use a language called Gherkin, and you write out in English exactly what the test is, exactly what the expected result is, and what a fail condition is. And that helps you kind of keep track of exactly what you're testing and not testing. Because if you're using something like Zap or AppScan or Burp or whatever, there's tons of tests. It's really hard for you to definitively know whether one thing got tested or not without going back through all the different tests that they offer and seeing if it's in that list. When you do behavior-driven development, you're being very explicit about the things that you want to be able to test. But the main thing is, if you're whether you build, you buy, or you borrow, always ask yourself whether you can maintain it after launch. Otherwise, you end up with that pile of gears at the end that no one's able to use. People who have, from the talks that I've seen and our experience inside, if you try to build a really large thing, it does take about 6 months to a year. I think Chimera, if I remember right, he said it took him about a year to build out. He probably had working components earlier than that, but to get to where he wanted to be able to launch it was about a year. So if you're going to do something that big, you want to be able to plan out the design into smaller chunks. Can you get smaller actionable pieces as you go, as opposed to taking on the entire project all at once? So you might want to do incremental design. At Adobe, we've done some of the projects we've been working on. We've been sort of segmenting out the different projects so that they can all be standalone and then just interface via APIs. And that's allowed us to get incremental successes as we build out the environment, as opposed to doing everything as one big architectural thing. If you look at all the designs, they always separate the tools from the core engine. They try to abstract the tools from the rest of the environment. And this is really important because you may need to switch out tools. You may need to use different tools for different environments. Maybe Burp's better at scanning the site than Zap because Burp deals with PHP better than Zap, or something to that effect. I don't know whether it's actually better or not, but that's an example, right? So if you keep the tools abstracted and you keep the idea around the test, and you're keeping measurable metrics designed around the test, you don't really care what tool got you the answer, as long as it got you the answer in a different way. And then the tools are going to be the things that you're going to probably Dockerize and scale out. So you want to keep those things separate from the core engine, because the core engine is just a queuing system that can be kept to a single machine or 2 machines. You want to separate data, the reporting of the data from the tool itself, so you want to have that as a separate environment. So anytime you've had to give data to executives, they always come to you and say, I want this way, I want it that way. Can you slice it up for me this way? Can you slice it up for me that way? By just like making an API where that stuff can be pulled, then they can go and pull it out and slice it up however they want to. They can put it in an Excel spreadsheet format that they want. If someone goes and uses it to create a pie chart and then Marcus fires them, the next person who comes in can just pull the raw data and start over again with a different chart that's not based on the pie chart. You want to plan for dynamic variables, of course, because you're going to be scanning lots of IPs and hosts. And this can be the hardest thing to do, especially if you're doing complex tools, which have to have the configuration per line. But it's something that you end up spending a lot of time thinking about, because usually your UI is where you put all this sort of stuff in. So if you look at those little minion, like they have the idea of plans, and there's a plan for each run, and that the plan is where they put all this specific information, so that the upload into the tool is basically a plan as opposed to, and in field 27, enter this piece of information. In field 28, enter this piece of information. So you want to have a plan for that. One of the projects I'm currently working on in terms of security automation is getting the picture of the organization. One of the challenges in deploying at scale is you may not have the list of everything that you need to be able to scan. And you want to scan against the stage environments, or you need to be able to scan against a specific dev environment, or are you going to go and scan everything in production because you need to measure production. So one of the projects I'm currently working on is I'm trying to get a holistic picture centrally within the organization, both from internal tools in terms of what we think we have, as well as external tools like the scans.io project to see what they think is associated with our organization. Because an association with the organization can sometimes be very nebulous. Yes, it can be a server that you run with a domain that you run and an IP that you own, or maybe it's a domain that you own that's pointing at a third-party service that you license. Or maybe it's a third-party, it's a customer, and that customer's, the domain is theirs, but the server is yours, right? And so you end up with those types of mappings in your environment when you try to do things at scale. And there's no really good way of answering that question without creating a database and starting with some stuff and then adding a bunch of metadata around it. Spend a lot of time thinking about the tools you're using. Like if you, in the Chimera talk and internally, we've used Zap, and Zap is great, but some of its documentation isn't there. So we've spent a lot of time emailing the Zap authors. And they've been great, they've been responding to us, but sometimes the tools don't have the granularity that you're looking for, like if you can only run one big test as opposed to that one specific test. Sometimes the tools need to listen on ports, and that can make it hard to be scalable because you can only have one tool per port. So maybe you need a tool that's actually more command line driven than GUI driven, where it's listening on a port, waiting for an API request. And those types of things can happen within with the tools that you're planning to run. So you want to spend some time thinking about that. And the answer is going to be different for each person. Everybody's going to have the tool that's right for their organization. But in terms of its scalability, you need to, does it listen on ports? Can I run the individual test? All of those types of things. And there is some stuff with REST APIs that I'm just going to kind of skim because we were running a little bit short on time. But one of the problems that you're going to have with going and scanning a large enterprise environment is you're going to have a lot of REST APIs. And the REST APIs are always hard because you can't spider them. There's no, if it's an HTML-driven site, it's great. You have crawlers and you can crawl the links. So you have to have some sort of alternative. And sometimes this is a Selenium script. Sometimes the way that I've heard of it solved in the past is what you do is you put the web applications tool into proxy mode, and then you take all of your unit tests, and you have the unit tests go run through the tool in proxy mode. While the tool's in proxy mode, it's recording all of the unit tests as a baseline, and then that's how you get the fingerprints of what your tool actually uses. But that requires you to go and work with the QE team, get access to a QE test, figure out if there's a way you can get those to proxy into the tool to create the baseline that you're going to use for your scan. So that can be a challenge when you're trying to do things across a large organization, because you'll miss entire swaths of things if they're just REST API driven. There's tons of decisions for platform choices. The insert lengthy technology debate here is actually intentionally left in by me, because I wasn't going to answer that for you. When we looked at some stuff, we were looking at Docker. And so to give like some practical examples to all this high level stuff, this is a tool that one of my colleagues, Mohit Kalra, wrote, where he was trying to solve automation through fingerprinting. And so there's a tool called WhatWeb, which will go talk to the server and try to figure out what it's running and what versions it has and stuff like that. It's a very simple tool. Comes on Kali, if you use Kali. And what he did is he sort of incorporated all these principles of design into his architecture. So he had a front-end web server for the static content. The front-end web server would talk to a WSGI server, which was all REST-based APIs. And he did that because he knew that while he would be using it through a web interface, and eventually he might have a tool which integrates into it, so he wanted to have a separate WSGI server so he could support APIs. So you put in a tool for you put in a request for either a scan to go have the scan done, or a search to go back and look at the statistics from the scans. They would go into a queue, and then there are Dockerized instances to run as many webbers as you needed to go do all the fingerprinting. And there's a number of search queues in case you're doing really heavy, once you've got that massive amount of data, if you need to split up the searches. So that was all Dockerized. And the types of technologies he used to make this happen, these are all the technologies he used. He used Python, which meant they used Celery as his event queuing system that's built on top of RabbitMQ. But you can see where this gets really complex, right? And this goes back to my original slides about like the clockwork architecture. That deploying these things out is going to take some time. It requires you to go read documentation of a bunch of different things to make it happen. So you want to sort of have a plan to compartmentalize it, what the technologies are, and how you can separate them out. Since he used Nginx, my IP thing is actually being based on Node.js, just because I wanted to do something different. But those design principles are another thing. So this is a design for Mozilla Minion. And as you can see, they've abstracted all their stuff out where they refer to the tools as plugins. The plugins are separated out from the queue system. Then they have a task engine, which keeps track of all the metadata, right? So it's, you'll see these same principles in design in the other tools that you look at. So go take a look at a bunch of things that have been deployed before. You'll find a lot of shortcuts and a lot of advantages to things in the way that you can design things, just by reviewing those. We are building a security automation framework that's assertion-based. We built it off of Gauntlet, so we've been using that as our bedline. And it's tool agnostic. It's one of those big massive things like Minion, like Chimera, which can go run any tool and come back with results. But we try to keep it in a very assertion-based method. And we're still building it out, still very alpha, so I couldn't share the code with you even if I wanted to. But it is designed out with very specific questions where is it yes/no based. And so we've done this. There are values in these things, but we spent a lot of time thinking about how we were going to design it before we actually tackled the implementation details. So we want to build towards automation in small steps. There's going to be a lot of steps along the way. You're going to use a lot of technologies. Being able to divvy it up not only makes it easier to scale in terms of like having the tools separated in terms from Docker, having REST-based APIs, all that sort of stuff. But it also means that you can get quick wins. Like if you're going to go tackle a year-long project, management may get impatient while you're off doing this. It's like, is this guy still doing this? I haven't heard from him in a while. Is he still coding on it? So if you design it in smaller chunks, it'll also allow you to be able to give feedback to management on the successes that are coming out of it, so you can keep giving them that feedback that this project's making progress and that there will be a value at the end of this track. So you want to be able to think those things out so that you can continue to give information. And then also so you get feedback on it. Like as you run the tools, you're going to get data that you didn't expect. You'll have to be able to plan for how to handle that. And the biggest thing that I run into is, like, I always have to remind myself, why not cron? like as I'm building this and it's getting onerous and it's getting big, you know, I always ask myself, like, what's the value add that this is going to bring that I could have just have gotten from running Zap in a cron job? And that'll keep you focused on the value of the project as opposed to just getting mired in the technical details of like what JavaScript framework you're going to use and what Docker platforms you're going to use and all that sort of stuff. So to wrap up, if you're going to tackle these things, it's great. They do add a lot of value to the organization. But know what you want to get out of it before you build. Spend a lot of time thinking about the statistics it's going to generate. Spend time thinking about, do you have the people to manage the output of it once it comes out? If you just build a bunch of web app tool reports, you'll have a great tool, but none of it's going to be actionable. So maybe, and if you have the tool as being designed as being tool agnostic, then one of the advantages of that design is you can go just switch to a different tool, which might be more actionable for the team. You have options in the design of it. And don't think that everything has to be at scale. Like if you can integrate some security checks just into the build process, use Jenkins, use Chef. We use Chef a lot to add security checks into things. GitHub has APIs you can run against it. Those types of things can oftentimes add a lot of value that doesn't involve this like, hey, let's go big with this cool large project that I'm building. And it'll be so cool once I'm done. And then just study prior art. Like teams like Netflix and Twitter. They've done a lot of this stuff before, and there's a lot of salient points in their presentations where they've gone through these lessons of trying to build out these large automation frameworks. I mean, yeah, it's really cool at the end when you can go to Netflix's GitHub account, you go and you steal everything they've got. We've done that in our organization. But think about what you want to be, try to think about what the challenges were, go listen to their talks, because it's more than just a tool. The tool has to be actionable, it has to be used operationally within the environment. So with that, I'm going to go ahead and wrap up. Does anyone have any questions? Yes? No, it's not, but they've talked about it. So you can go and look at what they've done. Yeah, well, the problem that they run into is because in order to have a truly useful tool that's actionable within your environment, you end up making a lot of decisions which are specific to your company. And so when they were looking at SADB, they were like, yeah, we can outsource it, but once we remove everything in the environment that's Twitter specific, it's just a shell. It's not something useful. But it's still really useful in their environment because they added that much customization to make it work within the flow. So there's some press articles about it. They've talked about it at security conferences before. It's a really good tool to go look at and learn from, even though you can't steal the code, because the code's an implementation detail. It's the architecture that's always hard to get right. Yeah, it is really abstracted. Like part of the reason why you end up with the pile of gears problem also is just because like when you built the tool, it worked for the technology that was there, but 5 years later, all the technology is different. And so that's part of the reason why you need to have that loose coupling and the ability to switch out those tools is because 5 years from now, your organization is going to look a lot different than day to day, and the tool which made sense 5 years ago is not going to make sense today. So you need to be able to, if you want to keep that framework and keep those metrics going, about the security of your environment, you need to have that flexibility to pull those tools out and pick the right ones in at the right time. Anything else? All right, so I'll go get lunch.